Good afternoon. My name is Jeff Ampar. I'm the Director of Product Management here at Cpine Software, and we'll be taking a look at some of the more advanced features of our load testing tool that's included with QA Wizard Pro 2011.2. With that, let's go ahead and get started. I should remind everybody that load testing shipped with a part of QA Wizard 2010.2, that shipped last month. It's a built-in part of QA Wizard Pro, and everyone who has a QA Wizard Pro license has a 5-user license to start testing, load testing, write some trial scripts, and then after that you can purchase additional virtual user licenses to replace those 5 temporary ones that we ship with every license of QA Wizard Pro. This afternoon we're going to be talking about a couple of topics. First, some alternative ways to control the load testing input. And we'll be looking at how to generate random input for some of your data. This can work well so you don't have everyone inputting just the same value, especially if the actual value isn't important as much as you see a range of values coming in. And the second is using our existing database integration so that you can pull sets of data from one of the many ways we let you store external data. Next, we'll look at how to analyze the web response and make sure that what you're getting back is what you intend to. There's a lot of different ways that a web server can respond to a request, and some are built in that QA Wizard catches, and others require you to look at the response and apply some logic. And then finally, we'll look at how to interpret the load testing graphs that we include with QA Wizard when you run a load test. Some approaches to looking at those graphs to help identify common server problems and some ways to maybe interpret that data better. And we'll also spend a little time inside of QA Wizard looking at some of those approaches within the tool itself. So we'll start off by how to control the input. And really, step one of that is to identify the input that you want to control. So when you're doing a normal automated test or regression test where you're interacting with the UI, QA Wizard records all the fields, lets you give them a human-readable name, and stores them in the repository, and gives you great hints when you're typing in there. We show you a preview of the field you're working with. With load testing, since we're not interacting directly with the user interface, it requires a little bit more work to figure out what is the thing you want to change and how to refer to it. So first, obviously, you have to figure out what are the things you want to vary with this test, as opposed to the things you're going to keep static with every test. In this case, we're looking at the version field. We're using our WYSICorp sample site. We don't want to just put in random first names and last names, but the version number isn't really important, but we want to make sure the server is seeing some distribution of version numbers. And this might be useful if the server stores them in the different database fields, or we're going to do some reports afterwards to make sure we see some variability in that field. So we need to identify the field and the form that we're going to work with. What we need to know, or what QA Wizard Pro for load testing needs to know, is what the name of the field is. So here we're looking at the source of that form we just were looking at the user interface of, and we can see that it's got a name of FNDB. And I'll show you when we jump over into the tool an alternative way to do that, but that's certainly one easy way, is to go to the web page, click View Source. I think all the normal browsers support that capability, and find that particular field and look for the name value. And that name value is the thing we're going to be looking for and that you're going to want to be able to identify in the script. So then we've got to go into our QA Wizard script and make those changes. And you'll see there's 2 lines highlighted here. The first one is where we're creating a random version number. In this case, we're using QA Wizard's built-in random function rand and saying pick a random number between 1 and 9. And then in the post field, down there at the bottom, or the post call, I should say, you see all the information that bug reporting form is going to send up. And we see one of those is that FNDB field, and we replace it from the hard-coded value that we had typed in when we recorded this test, but now use a QA Wizard variable. So just like any QA Wizard statement, you can use a variable instead of a hard-coded field. So in this case, we're using the version variable that we defined above, and we could do this for any of the ones down below. So the username or the email address, all of those could be pulled from someplace else, and we'll see that in a second when we look at how to do that from a database-driven script instead. But in this case, we pulled in a random number. Now we're going to use that instead for the web post, as opposed to the hard-coded value that was recorded with it. Alternatively, as I mentioned, you can also use our database functionality to do data-driven testing. So in this case, normally the easiest way is to use our open record set call, which lets you open a set of data from either a database, a local data sheet, one of the many ways we support storing external data. And then you can loop through the data, either trying to go through all of them, or just picking one row of interest, or possibly using a random value to pick one of the rows at random. So sort of combining the two to say, I'm going to get the nth row, where n is a random value between 1 and the number of rows in the database, and then use that instead. And to better illustrate both those approaches, I'm going to jump over to QWizard for a second and show you a couple of these. So first we'll see this is a QWizard script, pretty normal looking load test script. We see a number of web gets and web posts in here, and here's that FNDB value I talked about where we put the version in. This is a pretty much straight vanilla. I went in, and for specific web posts I want to put in random values. I mentioned there's another way to get what the name of the field is, and another way to do that is instead, if I went over here and actually recorded a new script, or more importantly, populated the repository. So I picked version 1 of my WYSICorp application and picked populate repository. It asked me to confirm that's what I want to do it for. I say yes, and we'll see I'm in here. I'm going to go ahead and log in. And right now it looks like a normal, actually non-load test record here. And I'm going to put a value in that version field. We'll say 2. And now I'm going to stop recording. And what's going to happen is QWizard now is going to see all the fields I interacted with on the 2 forms. I'll leave all the default names, though I certainly could come in here and give things better names. Let's say save. It did that. And now if I look down to that form I was on, first of all I get our normal QWizard feedback of the field I was talking about. I can see that's the one. And if I double click and bring that up, QWizard tells us everything that it recorded about that field. So its class, but more importantly, the name is right there, also down here in the name field. Its length, all the other important information. So if you don't want to look through the source of your HTML, or your source of your HTML is difficult to deal with, populating the repository as a sort of shortcut to get the information is a really convenient way to find that out. So you don't have to look through the source of your HTML, or if the development team isn't available for that. So I could come right in here and say, that's the one I was interested in. It's the FNDB field. So that's one. Let's look at a database one. In this case, I'm looking at a script that's a normal web get, web post we looked at before. In this case, I'm logging into the system, so I'm putting in the username and password. They were the ones I captured when I typed in, so I see the username is tester and the password is cpine. And that's sort of what you'd get if you recorded this script for a load test script out of the gate. I then created a data sheet, a local data sheet that has some information, some user IDs, a list of user names, and a list of passwords that go with them. And now I'm going to use that data sheet in a slightly modified version of that script. So if I jump back over to the database login script that's been modified now, you can see at this point I do an open record set on the database login. I pick a random user, one of the 3 I'm interested in, and then I go through and call next row until I find that random numbered user, and then I get the value from there and get the value for the username and password columns. All of this up to here is standard database-driven, data-driven scripts in QWizard, something you could do in any kind of QWizard script. And at that point, I have my new string values. In this case, they're strings, username and password, that I use instead for the login. So again, instead of having everyone log in under the exact same name, I can use this to make sure they're seeing a distribution of users. This would be great if different users have different privileges, maybe have different screens available, maybe have different parts of the screen available. So you're making sure you're touching the server in all the different pages, and can also test that when some people try to go to an admin screen, it fails for them appropriately, and for other people, they get to it. So you're giving a nice distribution to the server on the different kinds of users it would see. I'm going to jump back to the slide for a minute now. We're going to jump over to analyzing the web response. So how do you know what you got back was what you wanted? So there's first thing to know is that QA Wizard looks for the response and looks for defined HTML errors and will give you an error if one of those scripts fail. And those are things like 404, page not found, the kinds of errors that the actual web server gives back directly. But a lot of web applications, in trying to be well behaved, instead catch those and return back a friendly user page. So it might have some friendly whale on it, or a nice picture, or a friendly message trying to give you a more comforting feeling that the server didn't just crash, but rather that it's a bit confused and you should try again later. Well, QA Wizard can't tell whether that response is what you intended that screen to be, or whether it's in fact that friendly error page. So we treat all of those the same. So unless we get an error message back from the web server, we're going to come back to you in the script as if we got a normal response back. Every web get and web post call always returns the result back to you. Now I have here that it returns it as a string. For some of those, web posts specifically, it might return back binary data, for example, or a web get as well. If you did a web get for an image, it's going to return back a binary string, and there's really not much we can do with that. But if it does return back the normal HTML, so if it's an HTML response, then that comes back as a string, and now you can start manipulating that and verifying things are what you expect. So we have a number of built-in string functions, all of which have existed except for the 2 checkpoints for a while in QA Wizard, and all of these can be used with the HTML result you got back. So the first is find substring. So this is great if there's a specific string somewhere on the web page that you want to look for. So for example, if your script is supposed to say, or your page should say, welcome back, username, where the username is something in there, you could say find substring in the response for welcome back and make sure that's being displayed somewhere. Checkpoint string exists and checkpoint string not exists were 2 new functions we added around load testing, so they can be used for any kind of QA Wizard script, so they can also be used with the normal automation and regression tests. And those do exactly what you expect. They let you search a string to see if another string exists in it, and if it, in the case of checkpoint string exists, it will fail if it can't find the string, and conveniently checkpoint string not exists will fail if the string is there. So there's the two reverses of each other for you to look for something. So for example, you might say checkpoint string exists to make sure that welcome string is there because you want to fail right then, but you might do a checkpoint string not exists to look for your failure message to make sure that it doesn't exist there. So you would look for the string failure returned by server because that's what you display to the user. Evaluate regular expression is probably the most powerful version of these. This lets you search for arbitrary strings using the regex language. And so really, if you have some complex combinations of characters and numbers to look for and find information about, this really lets you do everything you could probably do and think of, but it's also the most complex to use because you have to create a regular expression and make sure it catches what you want. But if you really need to look for a complex string, that's the most flexible version of these. Then the last 2 really aren't ones for finding your strings in there. They're for finding pieces of information and taking advantage of the fact that it's HTML. So again, these are 2 we've already had in the product, HTML find by ID and HTML find by tag. Find by ID will search through your HTML for an item with that ID, and it will return the inner text value of that specific item. So it doesn't know what kind of thing it is, but it says, you've got something with this ID, find it and tell me what's inside of it. And that works really well if you have one of those things and you want to find it specifically by ID. Find by tag will actually get you everything of that type. So you can say find by tag input or find by tag image. It'll find all of those and, again, return the inner text of all of those back to you. So depending on what you're looking for, those can be really powerful to find them and, again, really take advantage of the fact that this is HTML and not just a generic string I'm dealing with. A couple of examples doing that. This is just an example we pulled out where I do a web get from an unknown shopping.com site. I have no idea what shopping.com is. I just made that URL up. But I said do a web get on that and return the result back as an HTML text. That's the name of the variable I'm using. So the first thing I said is do a checkpoint string not exists in there to make sure nowhere in there is the string sorry we failed. because our web server would put that in there if it has any kind of failure it can't deal with and tries to give you a friendly response. So if my script sees that, it'll immediately stop rather than try to go on and look for other things. So this works well in any kind of script, but in the load script specifically, so that you don't waste a lot of cycles looking for things that aren't going to be there, because we already know the server has returned back one of our friendly error pages. After that, so now I'm confident that I got back a page I expect to get, as opposed to our friendly error page. So now I do an HTML find by ID. I know somewhere in there is an item with ID ticket, or there should be anyways, and I put the result of that in my ticket num variable. And now I'm checking to see that should be something, because the rest of my logic is going to count on that ticket number and maybe use that as a parameter to a web post to check the status of my order, something like that. So I do another check to make sure that's not equal to the empty string. If it is, I'm going to fail right away, because again, the rest of my logic won't work. But if it does, I print out a line saying the ticket number is ticknum. More regularly, you'd probably in the else statement then go on with the rest of your statements, because if you're doing a load test, you'd have all these print lines coming out, and really what you probably want is just the ticket number so that you can do some processing with it. Let's move over now to some of the new graphs that come with the load testing. So there's a number of graphs that come at the end of a load test when you look at the report. The first you probably want to look at is the errors graph. And almost all the graphs, you'll want to compare them to the user count to see if there's a correlation there. But again, those errors are going to be a couple of kinds. First, any of those sorts of 404, the server gave back a low-level HTML error, we couldn't connect, the connection timed out, any of those sorts of very low-level errors, as well as any sort of fail statements or checkpoint statements you put in there will all show up as errors. And so you want to look for any sort of trend in the error line. Really, in general, you probably don't want to see any errors. You may have specific scripts where you do, but in general, you don't want to see any of those errors coming up. If you do see some of those, you'll see not infrequently some sort of sharp trend up. It might continue to go up to the end of your test. You might see a sharp trend up and then a constant steady state because your server is maxed out and some percentage of your virtual users are constantly getting connection errors. So you might see a plateau at some point. But in any respect, whenever you see that error line go up, there's usually something you need to investigate. And the first thing they usually do is try to correlate that with some user count. So in this case, we've looked and we see when we compare that to the virtual user count, that right around 22 is when we're doing that. So now if you start poking at that, try some other tests, and if always around, the low 20s, you start seeing an increase there, you can see that you've probably got some limit on your server that's not letting you get past there. So for example, you might be running out of database connections because it only is, you don't have a database pool, you're running out of connections around 20. So once that 20th person or so gets in, there's no more database connections, and you're going to need to look at some other way to maybe share connections or increase some limits on your server to take advantage of that. So the first step often is trying to correlate that with a number of users and seeing if there's some built-in limit on your server that you need to extend or improve. The next common error to look at is the response time. Again, you'll see this when usually there's an error is when you see sharp changes in that as the load increases. So certainly it isn't unusual for a normal server to sort of start getting a bit slower as the load gets up, especially at the highest ends. But you don't expect sharp changes. That usually means, again, you've hit some limit. Something's run out of space or time. And so you need to investigate where that is. And often, again, it's some limit on the server in terms of maximum number of connections it can allow, maximum database connections where people are having to queue up and wait after a certain number. And again, a common thing to correlate this with is the virtual user graph. Again, to try to look at, is there some maximum number of users your web server is configured to allow, and after that point it causes later users to have to wait till all the current users are out of the queue. So anytime you see these sharp changes in response time, that's usually an indicator that you've got some sort of limit on the server or limit in the environment that needs to be investigated. And then the last one I think we're going to look at is the bandwidth limits. And these, more often than showing sort of sharp spikes, tend to be plateaus. So In this case, it might be your network card, it might be something about your web server, it might be just your network in general, really limits how much information you can push out on the wire. And so in this case, we're seeing that after some number of users, I've plateaued and sort of stay at the same number of bytes per second, even though I've got more and more users coming in. So I'd expect that bytes per second to keep going up as we're servicing more and more users. So we see that after a certain while, it's just we can't shove any more information around. And again, we probably want to try to correlate that with some user count, but we're really looking at that slope and to see whether it should ideally be sort of following the slope of the virtual users, constantly rising in a similar pattern. So anytime we see it slow down or plateau or even worse, fall down and go in the negative direction, that's a sign that you've got some limit. Now, sometimes there are just limits. Your network can only push so many bytes around, and that's it. That's still an important thing to understand, and it's definitely important when you're doing load testing because you're going to start seeing other things like response time go up because you've throttled on your network, and you just have to know that. So you may have to change your server to a different platform, or you may just have to make sure your users are aware that under heavy load they're going to see extended response time. And maybe in your web pages you need to give them some feedback rather than just having them stare at the screen when they click the OK button and not know whether anything's going on. So you might want to try to look at places where you can give them some small feedback so that they know the server's gotten their request and is working on it and waiting for its turn to get some bandwidth out. Also, it's another good place to look at maybe using AJAX, some other mechanisms to download your data in the background or more on demand. So again, users get a better feel. They may get their core content immediately, but images and other things come down in the background at a slower rate because you know that you're going to be controlled by the amount of network bandwidth you have available. With that, just a couple of quick reminders, and then we'll see if there's any questions that we have a chance to answer. The first, just to remind everybody, we looked at some different ways to control the input, looking at either external databases or just putting it in the logic using random or other ways to generate that. Another one, if you allow guest access but require them to type in, create a username or put in an email address, would be to use that along with strings, combining strings and random numbers to get random login names. So again, you see some distribution as opposed to everyone coming in at the same time. Reminded everybody of all the different QA Wizard string functions, and really that any of the web-get or web post functions can return their result back so that you can look for them. And this is especially important if your web application tries to return back friendly errors as opposed to low-level 404 or dropped server connections, to try to look for those friendly error pages and trying to make sure you can find those and either record that those happened or even fail your script possibly so that you're recording when your server is returning back those sort of friendly error pages. And then last, how to interpret some different kinds of potential error conditions in your graphs, looking for those artificial peaks and spikes, and then also artificial plateaus, especially in the bandwidth, to see things sort of max out before your users count is maxed out.